Hello everyone, I'm Mrs. Struble, and in this video we're going to be discussing some basics when it comes to evaluating numerical expressions. So let's get started. Let's start with some vocabulary that you might see or hear in this video. First of all, we have a variable. A variable is a letter that is just simply used to represent a value that varies or we need to find it out. An expression. An expression is a mathematical statement with a combination of numbers, variables, and operations, whether it be addition, subtraction, multiplication, or division. An algebraic expression is an expression with at least one variable in it. We will see a couple of those here. We'll also come across something called a power. A power is an expression that represents repeated multiplication of the same factor. Within a power, we will have a base and an exponent. The base is that factor that is being multiplied by itself, and the exponent is a value that just represents how many times that base is going to be a factor. Lastly, we're going to discuss something called the order of operations, which is simply an algorithm to help us evaluate expressions involving more than one operation. Let's start with some basics of substitution. Substitution is when we have figured out a possible value of a variable. In these examples, we have the variable n in each expression. Therefore, if we are given a value for n, we can substitute or put in its place that value in order to identify how much this expression is worth. Let's do a simple example of if n is equal to 3. For the first one, if n is valued at 3, then 13n is the same as 13 times n. So we essentially have 13 times 3, because everywhere we see an n, we can substitute a 3. Evaluating that simple expression, we get 39. And we can do this with the other 3. 9 divided by n, if n is equal to 3, is just 9 divided by 3, which equals 3. N plus 8 becomes 3 plus 8, which is equal. And finally, n minus 1 becomes 3 minus 1. Let's take a look at this in a word problem. Problem number 5 says the total cost of seeing a movie at a theater can be represented by the expression A plus R, where A is the cost in dollars of admission and R is the cost in dollars of refreshments. Suppose you pay $7.50 for admission and $7.25 for refreshments. Find your total cost. In this example, they give us an expression of A plus R. From there, all we have to do is find the values in this specific case where we are going to use for A and for R. A is $7.50. That would be the cost of our admission that day. And R is $7.25, which is the cost of how much refreshments or drinks we bought that day. Putting those two values into the expression A plus R, we get $7.50 plus $7.25, which gives us a total spending value or cost of $14.75 to go to the movies that day. So what else could happen when we are given expressions and asked to evaluate them? Honestly, many things, and not all of them we are going to touch right here. We've got anything from square roots to fractions or any other rational number imaginable, and even double or triple brackets. But the next thing we're going to cover is the powers. First, let's talk about what they look like and how we read them or write them. Here are some examples of what we call powers. There's actually 4 examples here. We're going to practice writing the power in words and as a product of values, which is what a power tells us essentially. Okay, let's start with the first one. To read these, we start with the bigger value, which here is 7. And then we have a little sentence stem. We say 7 to the first power. 7 to the, getting that first from that little 1 up there. What does this mean as a product of values? Well, this just means that there is 7 being multiplied by itself, which is just 7. Let's go on to the next one. 5 with a little 2. Now remember, we start with the bigger value. So we're going to say this is read as 5 to the, that's your little sentence stem there. And then we have a little 2. So we could say second power, but there's a little trick when we have the 2. We could also say squared, and some of you might have heard of that already. What that means as a product is that there are 2 5s being multiplied together. So we have 5 times 5. Keep it going here. Use that real quick. The base, in this case, which remember is that bigger number that we see in a power, the base is 1/2. So we're just going to say half or 1/2, and then do that sentence stem to the third power. Now, just like the 2, we could use squared instead. We have a little shortcut for 3 also. 3, instead of saying the third power, we could say half cubed. Okay? Either one is correct. Again, that exponent is telling us how many times that base occurs. So there are 3 1/2s, like so, all being multiplied together as a product of numbers. And finally, the last one, z with a little 5. Okay? This is read as z to the, there's that little sentence stem there, crazy with that, and then 5th power. And from anything bigger than 3, we normally just say the number, whether it be end in a th or whatever, just like you would read a calendar date, and then power. We don't have any special word that we use like we do with the squared and the cubed generally. Okay. All right. Let's write this one as a product of values. We have z is our factor. That's happening 5 times. dozing off there. Lots of these. Okay, there you go. Right? So that's how we write them. Let's talk evaluating powers. I'm going to go through this section a little more quickly. Here we go. Evaluate the expression x to the fourth when x is equal to 2. This means that 2 is our factor being multiplied 4 times. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 16 would be our value of this expression. Evaluate the expression n cubed when n equals 1.5. So we have 1.5, and that's being multiplied not once, not twice, but 3 times. Do that math. 1.5 times 1.5 is 2 1/4 or 2.25. And then times that one more time by 1.5, and you get 3.375. All right, last one. Each edge of the medium-sized pop-up storage cube shown is 14 inches long. Okay, pop-up storage cube. Here you go. Just a little cube, guys. Okay. The storage cube is made so that it can be folded flat when not in use. Find the volume of the storage cube. In order to do this problem, we have to remember a little bit about volume, and volume being the sides cubed. Well, the sides are 14. So substitute 14 3 times, multiply it by itself 3 times. We get 2,744 inches cubed. All right, here we go. What happens when there's more than one thing we got to do? In that case, we use something we probably already know about. It's called the order of operations. So let's break it down. First, we evaluate any values within grouping symbols, whether they be parentheses, brackets, or braces. Okay, those are what we call grouping symbols. Then we evaluate any powers or exponents we got. After those are all taken care of, we multiply and divide. Here's the trick: from left to right. Doesn't matter if the division comes first or the multiplication comes first. We're doing them like we're reading a book. After multiplying and dividing is all done, then we can add and subtract. So let's practice the order of operations correctly here. All right, we're going to start over here on the left with number 1. Okay. Number 1, I see division, exponent, multiplication, and subtraction. Using the order of operations, also known as PEMDAS, okay, we easily see we do not have any grouping symbols, so we go straight to the exponents on this one. 3 squared is 9. After we do one step, we have to realize that that takes the place of where we were working. So instead of 3 squared, now what's there is 9. So everything else is still the same. We have 27 divided by 9 now, times 2 minus 3, okay? So our parentheses are done, exponents are now complete. We're going to multiply and divide from left to right. From left to right, 27 divided by 9. 27 divided by 9 gives us 3. Again, that takes the place of what we just did. So instead of 27 divided by 9, we can now substitute for 3, and everything else stays the same. Now, in previous years, you probably had to rewrite the whole thing just to show that you know nothing else changed in the statement. You might still want to do that. The division is all done, but we still have some multiplication going on. So we're going to do that. 3 times 2, 6. Now what's left is just the 6 minus 3. Our answer there is 3. Okay? Let's do number 2. There is another way to do this one. Okay? If you remember the distributive property at all, you'll know that there is another way by taking 7 as a factor and handing it out using multiplication to everything inside of those parentheses. Sometimes that's nice for us to do if we have variables inside the parentheses, but if we don't have variables in there, it just makes it more of a hassle. So this is why we would still do the operations within the grouping symbol in this case. So 13 minus 8 would be first, ideally, to get 5. Now, what do the parentheses mean? The parentheses mean multiplication. So we simply have 7 times 5, which gives us 35. Moving on to number 3. Again, we're working with those parentheses. I see parentheses, so I'm going to work inside of those first. We have exponents and plus. We're going to do those exponents first. 9 plus 1, get 10. All right, so 10 takes the place of everything in the parentheses. What's left is the 24 minus, so we have 24 minus 10, we get 14. All right, let's try this one. We have 2 sets of parentheses here. The trick is to work with the innermost one. So the regular parentheses would be considered the innermost parentheses here. And then we'll move out to the yellows, which are the brackets. Okay? So 8 plus 13, we get 21. And then we go to the yellow. And we say, well, 30 minus 21, that's just going to be 9. So all of this goes away and becomes 9. It's still within those brackets, which is another way to say multiplication. So we have 2 times 9, 18 is our final answer. All right. Now that we got the hang of it using values, let's talk about variables and practice that substitution once more. Okay. So in number 5, it asks us to evaluate the expression 9x over 3 times the quantity x plus 2 when x equals 4. Okay. Substitute. Everywhere we see x, we're going to put in that lovely 4, keeping in mind all the operations that are already there. We cannot get rid of those. Here's what I mean by that. Some are tempted to say, hey, that top number has to be 94. The 9 and the x are multiplying by each other. Okay? So you have to keep that operation of multiplication intact when you substitute. So the 9x is still 9 times x. The only difference is x is 4. So we're going to say just 9 times 4. Okay? In the denominator, 3 times 4 plus 2. Okay? All right. The next thing we need to be sure to know before continuing to evaluate this expression is what to do with this fraction bar. Now in this case, this fraction is essentially dividing the expression into 2 different sections of grouping symbols. Okay? So it's in itself acting as a grouping symbol would, in that it's saying, hey, keep all these top numbers together and keep all these bottom numbers together before you do the dividing. Okay? It wants you to do the numerator and the denominator first before dividing. All right? So let's go ahead and do that. Starting with the numerator, we got 9 times 4, 36. I'm going to write that over here. Okay. And then on the denominator, we have 3 times the quantity 4 plus 2. So we're going to do that 4 plus 2 inside the parentheses, get 6. 6 times 3, we get 18. Finally, we're going to do that division, which is 36 divided by 18, and we're going to get simple 2. All right, last one. A group of 12 students volunteer to collect litter for 1 day. A sponsor provides 3 juice drinks and 2 sandwiches for each student and pays $30 for trash bags. The sponsor's cost is given by this expression. So they give you the expression, that's nice, where J is the cost of the juice drink and S is the cost of a sandwich. If a juice drink costs $1.25 and the sandwich costs $2, what was the cost altogether? So eventually we'll get to the point where they're not going to give you this expression. You're going to have to figure that one out on your own based upon the information given to you in the text. They were nice enough to give that to us here because we're just kind of getting our feet dirty, so to speak. Okay. So let's use what we're given. Let's substitute what we know. We know that J is $1.25. We know from the one above that when a number is next to a variable like that, like 3 and J is, that means multiplication. And we know $2 is the cost of each sandwich. So we're going to multiply 2 times 2 there. I'm just going to put double parentheses. It's a lot easier for me than to try and get a little dot for that multiplication. All right, so now we have our expression working within those parentheses. Okay, we got a couple multiplication problems. We'll go ahead and do those. We got 4 over here. And we got 3 times 1 1/4, which is 3 3/4. 3 3/4 plus 4 is 7 3/4. Now we've got that value within the parentheses. Everything else falls down. That 12's out here, plus 30. All right, we got multiplication and addition. So we're going to do that multiplication first. And we're going to take 7 3/4 times 12. Once you do that, you end up with 93. Add that 30 on there, and you get $123 is how much they spent. All right, so this was a little bit winded, but it covers a lot of basics that we need to know in order to move on with expressions, dealing with expressions, how to evaluate them when there's multiple operations, how to handle those powers, and also just how to do simple substitution. Okay. All right. This is Mrs. Struble with Struble Math. See you next time, guys.